Okay. In number 11 and 12, we're adding and subtracting, and recall that with adding and subtracting, you need to have a common denominator. So before you find your common denominator, you're going to need to make sure you factor first. Remember, every single problem in this unit, you want to make sure you factor first. Factor first, factor first, factor first. It does not appear that either denominator here factors, because this is an entire term and this is an entire term. They're grouped together by addition, and there are no common factors and there's no squareds there, so there we have no factoring. So once you have it factored, we just want to make the denominators look the same. We need a common denominator. So we say, what's over here that's not over there? Looks like we're missing an r plus 2. So whatever you do to the bottom, you must do to the top. Looking at the second denominator, we need this to look like this now. So we already have the r plus 2, so we need an r plus 3. So whatever you do to the bottom, you must do to the top. We now have a common denominator. Our common denominator is r plus 2, r plus 3. So you can list that as one fraction now. And now we are going to combine our numerators. And as we do that, we're going to need to distribute. So we get 2r plus 6. Distribute a positive 3 now. We get plus 3r plus 9. We now have one fraction, so we can now combine up like terms. 2r plus 3r is 5r, plus 6 plus 9 is 15, over r plus 2, r plus 3. Now we would like to factor the numerator if possible to try to reduce this fraction. Is there a common factor? Appears to be a 5. So we could take a 5 out, which would leave you with an r plus 3. And apparently that r plus 3 could then cancel with an r plus 3, which leaves you with 5 over r plus 2 as your final answer. Okay, so that's the first adding problem. Let's move on to a subtraction problem. In number 12, again, we need to factor first. And there's always a temptation here to just put a minus 1 here. You can't come up with a common denominator that way. Common denominators have to be factors, and that's not a factor there. Factors are things that are multiplied, and this is subtraction here. So we need to factor this, and this is a difference of squares. R minus 1, R plus 1. That's what that denominator actually is. So now we need to make these denominators look the same. So apparently this fraction here is missing an x squared. So whatever you're going to do to the bottom, we are going to need to do to the top. So that gets an x squared on the top as well. And then over here, looks like we're missing both of these. And so we can go ahead and put in x minus 1, x plus 1 here in the bottom. And whatever you do to the bottom, you're going to need to do to the top. So this needs an x minus 1, x plus 1. So we now have a common denominator of x squared, x minus 1, x plus 1. So now we multiply this out, 2x times x squared, which is 2x cubed. And then here, I'm going to leave this minus here, and I'm going to put the answer to this in parentheses. Since we have a couple different things that need to get done, this needs to get FOILed out first, but we already know what this FOILs out to be because we started with it here. That's x squared minus 1. And remember, this subtraction is going to need to get distributed to both terms. So here we have 2x cubed minus x squared, and then plus 1, and then that's over your x squared, x minus 1, x plus 1. And here, this does not appear to be factorable. We cannot take out a common factor of x, and since this is a cubed, we can't factor this. So here is your simplified answer for number 12.